Hello and welcome back to Anton Math. Now we've been talking about relations, binary relations and compound relations, and in this video we're going to talk about inverse relations. Now if you think of a relation as kind of an action, as going from one set to another set, from one element to another element in the other set, a inverse relation is going to be kind of the opposite action. We're basically undoing whatever it is that the relation is doing. So let's have a definition. Every relation has an inverse relation. Now if sigma is a relation from S to T, we know then that sigma is a subset of S cross T. Then sigma inverse, and we use this to the power -1, this means inverse, is a relation from T to S. Or in other words, sigma inverse is going to be a subset of T cross S, where sigma inverse is all of the ordered pairs TS that correspond to ordered pairs ST in sigma. So in other words, if T sigma inverse S, that means that S sigma T, and vice versa. If S sigma T, then T sigma inverse S. So for example, let's say that my relationship sigma is equal to 1, 2, 3, 4, 4, 7, something like this, right, between two different sets S and T. Then my sigma inverse corresponding to sigma is going to be the ordered pairs 2, 1, 4, 3, and 7, 4. Oops. Right? So we can really just think of it, if we have a relationship sigma, the inverse is going to be taking all these ordered pairs and flipping the roles of the elements of the ordered pairs, and we get our sigma inverse. Right? So for every correspondence we have with sigma, we have the exact opposite correspondence with sigma inverse. Now we talked about composite relations, and composite relations have their own inverses as well. We have a theorem. If alpha and beta are binary relations from R to S and S to T respectively, right? That means alpha is a relation from R to S and beta is a relation from S to T. Then we know that beta composed with alpha is a relation from R to T. But we also know that beta composed with alpha inverse then is going to be a binary relation from T to R, right? It's the inverse of the binary relation beta composed with alpha. And we also have that beta composed with alpha inverse is going to be the same thing as alpha inverse composed with beta inverse. So let's think about what this last part means for a minute. If I have beta composed with alpha, that means I'm going from some little r to a little s through alpha, and I'm going from that same little s to a little t through beta. Now to undo that relation, or to do the exact opposite thing, I need to go through beta inverse to go from the little t to the little s, and then I need to go through alpha inverse to go from the little s to the little r. And that's exactly what this says here, isn't it? This means I'm going from beta inverse and then through alpha inverse to get to kind of reverse the relation that I had originally. Okay, so we can use this fact whenever we're talking about the inverses of composition to kind of distribute this inverse. We just have to remember that the order is going to be reversed. The order of composition in here is going to be reversed. Okay, and then we can distribute that inverse through. Alright, so that's it for the definition of inverse relations. Now in the next video I'm going to go through some examples, actually just one big example, talking about everything that we've done in this section so far. So we're going to talk about binary relations, compound relations, and relation inverses, and how we would do a particular problem that we might see dealing with this subject material. So we'll see you there.